Hi students, good afternoon. Welcome once again to ELE 2903, Sophomore Design Project Laboratory, experiment number 8, entitled Tinkercad Simulation, Distance Sensor Measurements using the Arduino. All right, so this experiment to be able to build an Arduino circuit using ultrasonic sensors and PIR sensors. No, it should be having here PIR sensor. All right. So we have two parts to do today. We have part A using ultrasonic sensors. Okay, I'm gonna build a circuit, Arduino circuit using ultrasonic sensors, and part two will be the PIR sensors. All right. So let us start with the first circuit, the ultrasonic sensor HCSR04 with Arduino. All right. So this project is all about ultrasonic sensor. Okay, and I'm gonna explain it how it works and show some features and share an Arduino project example. No. So we provide a schematic. I provide a schematic diagram on how to write ultrasonic sensor and an example sketch to use or code to use to your Arduino. So description. Okay, so the HCSR04 ultrasonic sensor uses a sonar, okay, sonar or a sound, to determine the distance to an object like bats do, okay, like we are doing in the navigational aids, equipments, right? So it offers excellent non-contact range detection with high accuracy and stable readings in an easy to use package. Okay, so from 2 cm to 400 cm or to 1 feet to 13 feet. Okay, its operation is not affected by sunlight or black material like sharp range finders. All right, so it comes completely with ultrasonic transmitter and it has also a receiver. So here are the features of this sensor. Power supply can handle up to 5 volts. Okay, the current the Q current less than 2 milliamps. The working current will be 15 milliamperes, and effectual angle, the angle of the effectivity, angle of this sensor is less than 15 degrees, and ranging from 2 cm to 400 cm, as I mentioned, and in terms of feet, from 1 feet to 13 feet. Okay, then resolution is about 0.3 cm, resolution. All right, and measuring angle will be 30 degrees, and trigger input pulse, the width will be 10 microsecond. So how does it work? So the ultrasonic sensor uses sonar, okay, to determine the distance of an object. So here what happens. So the transmitter or the trigger pin, okay. So we have 4 pins here, so we have the trigger pin, the echo pin, the ground, okay. The trigger pin will send signals, with a high frequency sound. All right. When the signal finds an object, or any object that is what you call this, in range, of the sound signal, it is reflected back, okay, and the transmitter, the echo pin, receive that reflection. Okay, so here the transmitter will send a signal, all right, to a certain object, and the signal will reflect back to the receiver. All right, and here's the distance, okay, so these are the reflective wave echo. All right, so the time between the transmission and reception of the signal allows us to calculate the distance to an object. This is possible because we know that the sound's velocity in the air. Okay, so here are the pinouts for the sensor, ultrasonic sensor. We have the BCC here and the trigger, okay, the echo and the ground. All right, so we have only 4 pins all in all. Okay. Okay, so in this project, we're going to have a project or a laboratory experiment that reads and writes the distance to an object in a serial monitor. Okay, using the serial monitor. So the goal of this project is to help you understand how this sensor works. Then you can use this example in your own projects. Okay, I think one of you already uses this sensor. All right. So parts required, you need to have Arduino Uno, okay, ultrasonic sensor, breadboard, and jumper wires. Okay. So actually, we're going to use the Tinkercad. No, we're going to simulate only. So follow the next schematic diagram, no, for this. All right. So let us try to implement this into the Tinkercad. So go to the Tinkercad. All right. So type Tinkercad, then log in. Okay. So okay. Actually, I'm already logged in. Okay. So I'm going to the circuits, then create new circuit. Okay. So click all components, all. Okay. So let us get an Arduino. Okay, type Arduino. So let's not components, photo components only. Arduino. Okay, here we go. Click and put it here. Then you need a breadboard as well. No? So breadboard. Okay, small breadboard will do. Okay, and a ultrasonic. No. Okay, so ultrasonic sensor. So choose the 4 pins. Okay, this one. No? Okay, so put it right here like this. Okay, make sure that the pins, no, these pins are connected to the breadboard. Okay, so let us go to the circuit. Sorry. Okay, all right. So now the VCC, connect it with the 5 volts and the ground to the ground. Okay, okay, the VCC here, connect it to 5 volts. Okay, the ground, connect it to the ground. Okay, this block. Okay, what's next? Now the trigger pin, connect it to pin number 11. Okay, and the echo will be 12. Okay, so trigger pin. Okay, all right, connect to the number 11. That's good. And the echo, okay, connect it to number 12. Okay, let's orange. Okay, there you go. So what you need to do is that, okay, write a code. Okay, so delete this and copy the code that I have been given to you, no? Here. Okay, this way. Okay, now this code, first it has setting up that the trigger pin is in 11, setting up the pins, no, of the ultrasonic, and we have the echo pin here, number 12, no? So we already connected it, no? And we have the long, that is the data type, that is a duration variable, and centimeter or cm or inches variables. Okay. Now to put us for to set up the pins. So first we need to establish first the serial monitor, no, by the code serial that begin 9600. No, this is the speed, okay, or the baud rate. All right. So then define the inputs and outputs. Then you have to do the pin mode trigger. Okay, the trigger pin, which is the trigger pin is 11 and echo pin is 12. And the trigger pin will be our output and the echo pin will be the input. And here's the void loop. So the digital write trigger pin low. Okay, and it's the delay microseconds. And digital write trigger pin high. Okay, so first it's low, then high. And the delay about 10 microseconds, then digital write trigger pin low. Okay, and for the pin mode, echo pin input, these are the duration. So pulse in, okay, the input during high, it will take and it will calculate the distance using this formula. Duration divided by 2 over 29.1. Okay, and it will print it in the serial pin. All right, so let us try to run this. Okay, so if you click this, no, so here's the distance, no. Okay, if you try to move the distance, no, closer, it will give you here, no, inches, 10 inches. The more the closer, the more the distance, no. I mean, okay, I mean not the more, the higher, no, the higher the distance, the higher the inches and the centimeter. Okay, like this. Okay, so that's it for the for part one. Okay, so what you need to do after doing the part one, okay, so do the classwork, no, so build the circuit again, modify, no, modify the circuit by adding a buzzer. Now if it is going closer, the buzzer will hear, you will gonna hear a sound, no. No, the the distance, the longer the distance, the buzzer will uh, try to have a sound. It will be having a soft sound, no, when it is moving towards to the sensor, or the distance is small, then the buzzer will, no, uh, sound high. All right, and write your observation. All right. So once done, then you need to do the part two, which is the Arduino with PIR motion sensor. Okay, this one, no, with the PIR. So in this project, we're going to create, no, in this experiment, we're going to create a simple circuit with an Arduino and a PIR motion sensor that can detect movement. Okay, so here are the required parts. No, you have this what you call this PIR sensor, LED, connection wires, and Arduino. And here's the schematic diagram. All right, so let's implement this to our Arduino or Tinkercad, okay, simulator. Okay, so let's delete this. This time we're gonna use the PIR. Okay, so look for the PIR sensor. Okay, here we go. Take this one and put it here, anywhere. Okay, the breadboard, no. Then connect the pins. Okay, so here's the red will be connected to the 5 volts. So from here, let's connect it to the 5 volts. Okay, and the yellow For the middle will be number 2. Okay, and third one here be the ground. Okay, so let's try the codes. Delete this. Okay, let's try the codes that I provided. This, copy all the codes. Right, so in the codes, wait a minute. Code, okay, so we are uh, declaring that LE LED variable is pin number 13, sensor will be number 2, state low, the val will be equal to 0. The variable to store the sensor status. Okay, right? So by default, no motion detected. Okay, at first, that's why it's low. Okay, and this the pin that sensor is attached, no, for 2 and 13. So void setup, pin mode, LED will be output, pin mode, sensor will be input, then serial begin. Okay, so that we can see the serial monitor. Then here are the void loop. Okay, so void loop. So val equals to digital read sensor. So first it will read, no, the sensor uh, input, no, output, no, and it stored it to val. Okay, it will read the sensor value. Then if the val is equal to high, so if check if the sensor is high, then digital LED will be high. Okay, then it will be having a delay 100 milliseconds. Then if state is equal to low, all right, the state is the motion, no? Motion is low to low serial that print motion detected. State high, update variable state to high. Else, digital write, LED if it's low, turn off the LED, and if the state is equal to high, then motion stop. All right, so let's start. I think we forgot some LED. Yeah, so we need to put LED here, 13 and ground. Right, so let's have an LED first. So LED. Okay, I'll put it here directly. Simulate. Hmm. Now, sorry, huh? Sorry. I think we have wrongly connected the PIR. Okay, so what you need to do, delete the yellow and the red. Okay, like this, delete it. Okay, so the output should be coming from the first. Okay, from here, like that. No, connect it to the number 2. So this is your yellow. Okay, the first pin. Okay, and the middle will be your VCC, that is 5 volts. Okay. All right, so please reconnect it again, no, with the correct connection. Okay, so Here's your code. Okay, this is the correct code, and start simulation. Okay, so click here, no? See, if every time I'm going to touch, no, or having a motion, no, motion, the LED will light up. See, there's a motion, then the LED will light up. Okay, and if the motion is out of range, see, the LED will switch off. All right, so that's it, no? So this is your experiment number 8. So what you need to do, again, for the classwork, modify the circuit by adding, okay, you have an LED already there, adding one LED and a buzzer, no, for part 1. So modify also the code accordingly. Show your correct output to the instructor. So no need to show to me. You can send it directly, no, to by your report. Okay, and write your observation in each part. Okay, so submit a complete laboratory report for part 1 and part 2. For both, huh? This is lab 8. Okay, all right. Thank you. Thanks for watching and good luck.